Alrighty. Happy Monday. Sorry to miss you last week. I think I'm mostly over it now. It's not been a great winter. So hopefully you all doing well. Um, we've got RegEx. This will be pretty quick. There's a lot we can do with it. We're not going to spend too much time going crazy deep. It works the same way in all different languages. Here, we're just looking at how we do regular expressions in Python. Have you seen regular expressions anywhere else before? Or is this brand new for RegEx, regular expressions? Okay, we can spend a little more time if we need to on it, and then we'll get into networked programs here. This is lots of fun. Once we start being able to actually connect over the network to other applications and do other things with Python, so it's not just something running locally here. It gives us a lot of flexibility. Chapter 13 gives us more. We do more fun things with our web services, and that's probably more fun than just the basic network stuff. We'll see how far we get this week on that. And then we've got project one is due Wednesday. So we'll go over that first thing Wednesday, pick up wherever we left off here. Um, I'm sorry, two. I can't count here. Project two, uh, Wednesday for that one. All right. All right. Let me fire up PyCharm. So regular expressions or regex here is how we find particular matches. Now he's got some nice easy links here. Um, regex 101 is probably really handy here more than any of the other sites because you can try out your regular expression to see, does this pattern match something here? And that's what regular expressions are all about, is how do we see if a particular pattern fits? They're saying, hey, this is all the different possibilities that I want to find here. Go and find where it matches. So we can go through large strings and look for given patterns here. Let's see if they contain any of them. Why is it not loading here? Nothing, really. All right, that's kind of sad. But built into Python, we have the RE library here. So we can go start this one. What's this here? Week 5. The load for us. There it goes. So looks kind of like a crazy site here. That's okay. So what it lets you do is you enter your regular expression at the top, and you can test a bunch of different strings here, and it'll show you which one it matches on here. So if you wanted to find, say, something with an E in it here, so use the square braces, and then this is just a single character E here. So it finds an E in Eric, right? Was looking for an E. That was pretty easy. Um, so like trying to think of a word that ends in E. There's so many of them, and I'm so tired right now. I need more coffee. Coffee. Coffee doesn't match, right? It's case sensitive, but coffee. It finds two E's. Very exciting. So it's going to find things. Now, finding a single letter is not very interesting, right? That's not the most powerful thing we can do with regular expressions, but it'll go and look for given matches. So this site lets you test them out here on whatever we're looking for. So for some reason, Dr. Shuck likes to take whatever this what was it, our mailbox mail messages and go through and try and parse them, read through them, try and find given strings in here. So if we're saying, hey, I want to find the from bit here, you've got some extra cool characters and things we can use. So this little caret here, I don't know if you can see, let me zoom in a little bit here. This says, I want to find something that starts with this here. So on any given line, it's only going to match if it starts with the word from here. And then we get some wildcard symbols. So say, let's match anything here. So the dot here says any given character here. And then the plus means one or more times. So as long as it says from, and then there's something else there, some number of times here, and then an @ sign. here. So it will look for a line that starts with that. I put it back in the tester here. So starting from here, and it's kind of cool. It like talks you through what we're trying to do here. So it says, hey, we're starting at the line here. This matches any character except for line terminators. It matches the previous token one or more times here, and then the literal at sign. So if we take his text here, did he have it? Is it? Remember if he had the text here? I think you had to download the where his message was from. Um, yeah, his mailbox. Shoot. Uh, sure. There was a line. You can throw that one in. So if it's not matching the particular syntax we're looking for, it's not going to match. Now this one's pretty close, but this one has the colon in here. So it's looking specifically for from colon. So regular expressions let us do pattern matching. So we can take some large input here, say I want to find instances where we're going to match this particular pattern. So other silly things we can do if you know credit card numbers, right, they're 4 digits and 4 digits and 4 digits and 4 digits. We can take some big chunk of string input and look for credit card numbers. We can look for given keys, security keys, all sorts of things that we know what the pattern looks like here. Um, there's all sorts of people out there who have nothing better to do with their lives. Um, and if you go to GitHub and you have a public repository and you publish a key like your Amazon key that lets people go and start servers and things and use your Amazon services, within 5 minutes or so, someone will have spun up a lot of Amazon Web Services trying to mine Bitcoin using your money. They just crawl and wait for, and they do pattern matching. Say, hey, let me go and find something that looks like a key here, and they just watch all new repositories that show up. They can do that with regular expressions. So we can look for given patterns, which is a lot of fun. If you want to scan through a big text dump of output here and say, hey, I want to look for things that are social security numbers, right? 3 digits, dash, 2 digits, dash, 4 digits. We can do those sorts of things. Um, they also have really good uses too. When we're dealing with all sorts of weird inputs and texts and things, it's hard to know what you're going to get. Um, so matches the first at sign here with our the question mark. So he gave you this line here. This one's fun. So this entire chunk here matches because it was one or more characters, and the at sign is a character going to an at sign. So this idea of matching is pretty tricky. Here we have to be rather specific about what we want here. Um, most people spend lots of time playing and testing and trying to get a regular expression just right here, and then we never touch it again for months and months and months, and we come back and we forgot all of it. We have to go look it up again. That's really common. That's okay. Um, if you remember, I think it was last year. I think it was last year. Someone at Cloudflare, they're like a internet cache, like a front end side that hosts a bunch of stuff here. One of their team members updated a regular expression and took down a third of the internet because the regular expression was doing a bad thing here. That was a whole. I think it was Cloudflare, right? Yep. Look at that. It was even a search I did before here. 27-minute global outage due to a poorly written regular expression in their web application firewall rule. Catastrophic backtracking, exhausting CPU resource. You guys can read, sorry. So it sounds really fun. Um, this was their regex here. I don't even know what this thing does here. So sites like this are really fun. Hopefully it'll explain it. Sort of. Oh man. Looking for something in here. I don't even know what this was trying to do. It's what was that's hang on. At some point, if you spend enough time, using the lazy quantifiers. Right? This is the piece. This is what made me think of it here. Using our greedy or lazy quantifier with the question mark here. Um, reduces the backtracking. It's not really exactly what they wanted here, but sort of what they were looking for. Um, yeah, they even posted about it on their blog. That was really cool. It's like 2019. I really thought it was like last year. 2019 wasn't last year. I know, right? Man. Okay. It just kind of all ran together after 2020. Um, yeah, that's the CPU usage graph. Oh, that's a sad graph. This one here. Uh, yeah, just a minor change. I think they have where they're talking about it, right? In here somewhere? Yeah. Mm. Didn't have complexity guarantees, didn't stop their CPU consumption. Ooh, using other libraries. Here you go. So you can use a better library with runtime guarantees so it doesn't just backtrack forever. This one here. Question colon this pattern. They're just looking for essentially IP addresses, looks like. Okay, something dot and a star, something dot star, but they kept going around here. Oh man. So this matches the first one, which also matches the next one. Right, so the string you had in before here, where is it? That one. Right, where it matches this one, this part matches, and this part matches, and this part matches. It's all very exciting, sorry. Um, it's difficult. Now, thankfully, chatbots are getting pretty good at regular expressions, but we don't want to trust them completely. Right? Like any good thing, we should just take what they give us and say, oh, it must be fine. So putting it through lots of testing to make sure it does what we expect it to do is rather important. Right? Don't want to take down half the internet, cause a global outage for 27 minutes. That makes for a bad day here. So if we do come up with regular expressions, right, you can use, oh, here's the backtracker. There we go. So it's looking through the match here just with a single 23 steps. Nice. Yeah, so any string, okay, there we go. The number of times it matches, the number of steps it takes to match. So this got bad pretty quick. Um, now we don't need to do anything that complex most of the time, thankfully. We're trying to look for things with our regular expressions. But you can take a bunch of text, look for given patterns here. So things that we can give it here, if you want like a bunch of different characters here, like anything with a vowel, we put it in square braces and it will match any one of those characters here as long as it exists in the group. So we can say, hey, I want to go find something with a vowel in it. Okay, and this one is going to go find it. So let's go back to the Python code. That's much more interesting here. Sorry. So if you actually want to go and grab something, we're going to say, hey, I want to find everything that matches here. So we use the regular expression library and say, oh, okay, find all from a given string. So it's going to find the matches in the string here that match this code, that match the regular expression that we're looking for. So let me go import regular expressions and this one looking for a range of characters. Let me zoom that in again, sorry. So it'll match anything lowercase a to z, anything uppercase a to z, and then a digit 0 to 9 here. You match anything like that. And then we've got flashes. So we get a bunch of escaped characters we can use. So the non-blank character is our S here. And then the star is 0 or more characters, where the plus was 1 or more. So before we had, where was this plus here? Right, we said 1 or more something characters here with a dot. Any given character, 1 or more of those. This one is saying we want 0 or more is okay because we want a single letter, right? Some character, a bunch of other characters here, 0 or more, at something here, 0 more times, ending with another letter. So this way we don't end with just, .2, .3, .4, right? Probably .com, .org, but we don't have to list out every single possible domain because there's lots of different domains nowadays here. I don't think it'd be fun to list all those out here. So we can put that in our tester here, throw in some email addresses here, and it's going to match the email address. Right? So it starts with a character here. So if I tried something that was not like if I tried like a special character in here, I'm not going to match the special character part here. That's not an A to Z 0 to 9. Right? So that one's going to get pulled out when we try and do the match here. And we go all the way from the @ sign to the ending here, which is pretty cool. So if we give it a bunch of text, let me grab, see, I think that he's got his file somewhere. It'd be fun to go steal, but that's okay. Is it this one? That's just the code. I don't think that's not his file. Where did he have his file? Did he say where his file was? I don't think he did. That's okay. All right. So if we want to go and match with our regular expressions here, so we're going to search for a given thing. Now, search will tell you if it exists here in that line, right? Where the find all will give us the ones that match, right? We get some sort of list here. Oh yeah, here was his message. There, this one goes better. So it's going to find all of the patterns that match this here and print them out as a list. So we get our email addresses here. So just the pieces that fit the regular expression come back from the find all. So we don't get the entire line that it existed in. We just get what was found here. Again, if we get some large dump of data and we're looking for particular patterns and numbers, patterns and letters, given keys, we can match those relatively quickly here. Like if you want a regex for AWS key. Here's your pattern, right? Oops. Oh goodness. Clicked too hard. So A to Z, 0 to 9, and 1 or more, right? 40 characters. Right? There's got to be a slash in there, and then 40 characters long. This one's 16 characters long. Starts with A Kia. I don't know why. Or A SIA. The Amazon keys. A to Z, 0 to 9. No lowercase here for that one. Right? So we're only using the uppercase. Can we see those? Sorry. Yeah. So we can kind of quickly go through if we get any sort of file. See, did we find any keys in here? So you can add in sort of checks as well to make sure that you're not putting files out and putting your keys out by quickly scanning your stuff. That's a relatively common step nowadays for people who have cloud hosted services. Before we actually commit our code to the repository, you can run a scanner that says, hey, make sure I didn't put my key in my code, because that's a really bad thing to go do and push your key out where people can go get it. Oh, there we go. Temporary credentials. There we go. Versus the IKEA, the long-term ones. All right. So if we wanted to scan our code, let's see if we can find these ones here. We'll just we'll steal that one here. And what was this? This was our Bing search. Or regex for AWS key. All right. So we want to go and scan our code and see if we can find any of those keys here, right? And sure, see if it matches a key or steal those ones already. Those ones. I just want to go find them here. So how do we make a little function here? So we'll like check for key given some text, right? And if we can find this here, we'll just we'll go back to the search one here. Wow, that got way too big here. Sorry. Didn't we have, is it this one here? There we go. Matches. That's the one we were going to steal. We have our patterns. Don't need the sample keys. And if we can match here on the text, and return true. And we can check the next match, right? And if we're just saying, hey, if something's true, return true, you can just return that. Oops, here. That one matches or that one matches. So if I wanted to be able to go through and scan my code, right, we did some fun stuff with files, right? Did I show you the OS walk function? I don't remember if that was in there. So uh, OS walk. There's a cool recursive function in Python that you give it a directory and it will go through and give you everything in that directory, including the subfolders and files. And if it's a subfolder, you can open that subfolder and get all the files out. Or if that subfolder has subfolders, it'll open the subfolders and the subfolders and the subfolders, as far as you want to go without it being too difficult here, right? We just start, oh, I don't want the actual code. I just want to use it. There we go, right? So we say, okay, walk a given directory and you'll get that directory, you'll get all the subdirectories, and you get all the files. If it's a file, we can go look for that file here and say, okay, hey, is that a Python file? Right? And then we can go get the text of that Python file if we want here, and it will recursively open up every folder inside of this one, inside of this one, inside of this one, inside of this one. It'll work its way through every one of these directories here, which is really cool. So you start with directory path here, and then it will give you the next one here. And then when that loop is done, it'll come back and give you the next list of files is the subfolder, and the next list of files is the subfolder. So if I wanted to scan all of my code and look for keys here, we can just quickly walk through the given directory. So let's scan, let's go import OS. Python here. Then let's see if the contents of that file, right? We'll check that contents of the file for a key, right? So we've got the file. I need the text is file.read. Or no, we got to open it first. So with open file as code, text is code.read. Now we can just read everything, right, all out at once. We could read it in individual lines, but then we have to check every line at a time. Like we can just take in the whole thing. Could be a couple thousand lines. Could be a really big file. It's probably going to be okay. I don't think it will have any code files that are ridiculously large here. A couple thousand lines is still plenty small enough for us to read in here. So let's see if we can find a match. So we'll check for keys. If check for key given the text, let's print key found in, and then we want like the name of that file, right? And maybe what the key was. Maybe just the name of the file, I guess. File. All right. So let's try and see if we can print out that we found a file. So we don't want just dot here. Let's go ask for what folder. So we get a directory, an input of enter a folder, scan for keys. I don't actually care about the top-down thing. That should be fine. And we'll give it the directory. And then just for fun, you can print out some of this information as we're going here. Just wanted to uh, print, uh, is it root, I think? As we go, and we'll see the root change. It should be able to see the root change as we go here. So should we take some of those sample keys? I think we had some of those sample keys in here, right? Let's take 2 sample keys and just throw them in our code here for fun. Why is it on like text? Oh, that's fine. So we should be able to detect that we've got sample keys in here, assuming those regex worked. All right, so if we go scan our own week 5 folder here, so we can go open this in Explorer. I can copy my week 5 path here. Actually, let's do the whole GitHub directory and see how well that goes. Give it a run. All right, so a folder to scan for keys. Let's say, hey, scan the whole CIS 298 directory here. Let's give it a quick scan. So it went through, oh, the Git folder, Git objects. Oh, that's exciting. All the Git stuff. Uh-oh. Didn't actually find a file. All right, so if it didn't actually open, that's probably okay if we can ignore it here, right? Huh, why did it not? Probably don't need to be in this folder anyway. That's okay. So we'll say if root, is it the DIRs? Which one is it here? Because we want to ignore any folder that starts with the dot here. How do we get that one here? At the slash dot? Dot contains. We should use a regex for that too, right? So look for, let's search it here. Let's do GPT. We'll have some fun with chatbot and see if it works for us here. So write Python, or just any regex, right? That takes a file path and looks for a hidden folder, starts with a dot. See if they can figure it out for us here. That should be looking for a slash and a dot. Yeah, so here's the hidden folder. Looking for, definitely there's the dot, right? I think there's the slash. All right, let's see what it says here. Put this into our little regex tester. I did not like it. Oh, because it had to be as a raw. This R in Python, do we look at the R raw strings so you don't have to do escaping? So you can tell Python, hey, I'm going to give you special characters here, like a backslash, and please don't treat it like an escape character here. I think that's why it's upset with us, because we have the backslash and the forward slash. Yeah, unescaped delimiter must be escaped. Backslash one of those. Oh my goodness, that's obnoxious. So looking behind, looking for a character, a forward slash character, matches a dot. All right, so let's see if we give it a couple of these paths here. Does it match? No, because we have backslashes in Windows, not forward slashes. That's fun. Can I do backslashes then? Backslash, backslash. All right, so it's finding it here. In Windows land, you have backslashes. In Mac and Linux, you have forward slashes. I don't know why people decided to use different ones, and it drives me crazy. All right, so now we're finding the hidden folder here, right? So I think that's a good sign. So if we find the hidden folder, we want to skip it here. So if re dot match here, so this was our pattern here. Why does it not like redundant escaped character? Okay, sure. No. Here was our string. Oh, that's right, a raw string. So now we can take out the escapes here, I think. Doesn't like string here. There's the start, there's the end. Wow, that got ugly. Maybe double quotes. Would I be happier with double quotes? Still just as unhappy. Redundant escape character. Yeah, redundant escape character. Escaping third parenthesis. Yeah, why? I don't want that. I just want the code here. Was that any different than the other one? uh, that one we want forward slashes on. I don't undo. That backslash didn't like. That one it did like. That's crazy. All right, let's see if we can fix them here though. Backslash, backslash, backslash. Okay, maybe that'll do it here. So if that matches the nope, we lost it. This is what as soon as I put the comma in, they lose it. Changing my slashes. Root. If it matches the root, continue. All right, let's see. Let's give it a try. No, that's not. Oh, because I never changed these ones here, right? It should be the backslash dot. That one? The backslash. You have to escape those ones. Still trying to read it here. Shoot. All right. We'll just be really hacky here because I wanted to actually get through here. So try and accept. Is this a file not found error? Continue. Oh, not that. This one here. Just wanted to scan my files. Right? I didn't get the main one. I never got the main PY. Forget that for a second. No, it's not finding that one. Oh, I don't think I want to continue here. Just pass. We don't want it to go to the next one. We'll just finish. Did I do it? Are we finding it? Not finding it. Where? Should have gotten it from this one. This was root. It should have been in the list of files. File ends with py. Do it. Is it not? That's the right path. So this was going to go a whole lot better in my head. Um, why did we never get files there? Let me see what files exist here. There's our big ugly list here. Yeah, okay, it has the list of files. So it should have gotten the very first one. File and files. File ends with py. All right. Oh, I got it. I got it. We were just printing out the list of directories here, not the actual files itself here. That was what was happening. All right, so let's see if it'll read it here. Can it read itself? No, file ends with py. Oh, my open file is incorrect here. So I need the name of the file. I need to add to the folder name here. So when we saw when I printed files, that's what happens when you skip the example. So files here is just the name of the file, not the entire path. So if I try and open here, I'm just saying, hey, open this one. You might not find it here. I need to give it the whole path. So we need to, so let's join. We can take the root and the file. Join? No, not join. OS. Is it path? It might be path. No? There's one that joins these together for me here. Trying to remember which one it was. Name, open, no. All right, hang on. I thought join file. The full path. Oh, path.join. So close. OS path.join. Path.join. The root in the file. See if that one opens here. All right, that was closer. It did not like reading something. Trying to read. Goodness. I don't know what file we were going to try to read there. All right, hey, we found our main PY. So let's see if we can pull out the text here then. So let's step over. We've got our text. It should be able to find a key then, right? So check for keys. Was it not? It's got our pattern. And if we can match that pattern. Did not find the key. So something in our regex didn't seem to work for us here. Seems like. All of that to get a bad regex. Let's go back and see. Let's put it back in our tester. This is why regular expressions are lots of fun. Is it the stupid slash here? Really? This whole thing because of slashes? All right, let's see then our sample key, if we can find that. All right, it doesn't find it there. Interesting. Oh, it doesn't run with example key, right? Or is that the end of it? Example key? Example? All right, looks like it should have. Telling you, these finding keys is tough. Is it the strings in here? There we go. So the quotes in there made it not find it. Okay, so that one matches here. That one should find a key on that string here. Is that what we had there? Oh, this one. So I added in a slash there, right? Let's try this one. So we needed. Oh yeah, and that one matches. Okay, so those ones match. So we'll see if it can find it. So close. Find a key? Didn't find a key. I'm going to try it line by line, I guess. Line, read lines, for line and lines. Check every line maybe. Let's see if that gives us any better result. Still not finding it. It should be picking up the keys in our file here, right? Let's see if it picks it up. Import OS, sample keys. All right, so here was the line here, right? There's the A key, AKIA one. So you should be able to check for that one here. That one matched, right? So we're returning that one matches or that one matches. Access pattern, secret pattern in the given text. Let's try copying that whole line over. So in our regular expression here, we added in the $sign says this is the end of a line, and the caret says it's the start of a line. So we don't want any given line, or that we don't want the start and end. We want it to be anywhere in there. So if we remove those start and ends, it should be a little bit happier here. And it should find it. So we'll get rid of these start and end qualifiers. I think that ought to find it. Not secret key. Nope, that didn't work. Folder name. Come on. Really? That one should have found it now. So this one? Okay, because it's finding it in that line now. Check for keys. Finds the line. Nope. We're trying to use the check for key function. I guess we can skip our function. It was not very helpful here. Sample keys. All right, here's the line here. Did we match? Oh goodness, yeah, we don't want to file that. Didn't return. Secret key. Not doing the right match here? Yes, it matches. Pattern in the string. Let's try. Let's go back. Just test it out here. So if match this one. And our sample key. Like a redundant escape character? Right, it is matching here on that string. Is it not like this escaped? Right, test match is good so far. So maybe get rid of that escape character. Return the match in the text. Maybe we're doing too much. Let's take this one here. Can we throw in secret key? Equals that? Oh, so that did break it. Did not find that. We should have, because it's finding it on our tester. right? It's finding a match. So we didn't need that one. The tester wants the escape sequence. So as soon as we added something to the front here, it doesn't match it. That's interesting. That one matches. If we add something else, it doesn't. A to Z. Test. Let's just using our match and it was finding it. Interesting. Not. Is it looking? I think it's looking exactly for 40 characters. Is that what that one's doing? Oh, but if finding it matches it 40 times, looking for 40 matches, and it finds it in there, finding the match. Z. Right. The other hacky thing we can do then, I guess, is we can split this then, right? So for token in line dot split, let's check the tokens. We'll break it down one at a time here. That ought to get it for us. We'll get it one way or the other. Look at the path. There we go. Hey, and I found a key. But I found it in exceptions.py. What exceptions did we put that in? That's interesting. Key found in utils.py. Did it not find it in main? It didn't find it in main. It's finding keys in other files. That's not helpful. All right. Did not. Still didn't find it in our main file. I'm so sad. Because our code is because we have quotes. Might be because we have quotes. No, it saw it in there. I think it's because of the quotes. Yeah, that's so depressing. Here, so let's add in then a quote and a quote and a quote and a quote. Hey, we found a key in main. We can make our regular expressions match. This is why they're lots of fun. But if you fiddle with it enough and you can get it to finally actually match the thing you're looking for, now we can actually scan all of our code everywhere. And again, it needs a little bit of work to avoid some of these folders you don't care about and not crash on things. But we're getting closer, right? And people already have these sorts of scripts. The writing one by hand was not. It is more of an exercise here and having some fun. But before we push our code, right, make sure it's scanned. Make sure we don't put some keys out there. Anything we're looking for that's sensitive data, we can go scan relatively quickly here, right? Looking for any of these. Now, trying to find individual matches before we had regex was not going to work very well, right? We can do like a starts with, we can do a contains, but looking for any of these sort of wildcard matches here is going to be hard to do. So lots of cool things you can do with regex, parsing text. For some reason I got fixated on this example here and really wanted it to work. But that ought to go for us for here. All right. I think that was the end of his regex. Yeah, finding finds, give us the ones that match. Yeah, looking for other details, splitting from escaping characters. Yeah, we did that. All right. Oh, so here's this list of all the matching stuff here. The beginning of the line, like so, it has to start at the beginning of the line. End of the line has to end at the end of the line. Um, any character, any white space, any non-white space, capital S versus lowercase s, zero or more times matching, zero or more times in non-greedy mode, one or more times in non-greedy mode. Immediately preceding character zero or one time, zero or one in non-greedy mode. Any character in the list, right? The range of characters. This is not this range of characters here. So you can invert. That one is kind of fun. And then parentheses get you the subset that matches. E is for empty at the start, empty but not at the start. D for digit, essentially or 0 to 9. And then non-digits or the inverse of 0 to 9 here. So if you like Linux, Unix, you get grep. It's a built-in regex finder, which is really fun. And then yeah, debugging regex is rough, as you can see. That was fun. Oh, that's okay. So we must have had the file in his GitHub here. We could have found it here. All right. Was that a very fun deep dive into regex? It was entertaining. I had fun. All right. Let's move on to networked programs here. So again, this just sort of starts here. When we get to chapter 13, we do a whole lot more with it. If you haven't taken a networking class before, this will be a little deep, but that's okay. We'll get there. So essentially, we connect over sockets here. So network connection uses a particular socket to connect to somewhere else, right, over that socket here. So that's the two-way connection here. So you can read and write from that given socket. So it's you have a pipe open there. You can send stuff back and forth here. If it hasn't sent anything, we just sort of sit there and wait. So like, I'm waiting to read. They haven't sent me anything yet. There's nothing to read yet. So it gets to be interesting here to just sit and wait and spin your wheels, waiting for some data to come through here. With our HTTP, the internet runs on our hypertext transfer protocol. We can go and get information from a browser, from this website hosted online, and get it back. Right? So really quickly here, we can start our socket here, connect to a given location. Now, HTTP runs on port 80. There's a whole list of ports that we use, and different services will use different ports here. That's sort of how we distinguish where it is. So your computer can host a bunch of different things all at once. So 80 is for HTTP traffic. 443 is for our secure HTTPS traffic here. Most everything should run on HTTPS nowadays. All sorts of other services have, so there's like a list of common ports here. Don't bother memorizing them here, but here's a whole bunch. Telnet is 23. SSH runs on 22. What other ones are fun? DNS runs on 53. That's a popular one. Our domain name service. We can use names instead of IP addresses for everything here. 80s for HTTP. Again, whole list of them here. And then once you get above a certain range, my goodness, there's way too many of these here. You have dynamic ports from 1024 to 49,000 or so here that can be used. Sometimes we'll use them for certain things here. And then above that range, even higher than, we can get other ports. Where did that list go? Yeah, above that, now we can start using whatever we want here. So if you want to write your own service that listens on a given port here, use one that's not used somewhere else. It's not registered somewhere else. It's probably pretty safe. And then people can connect over it here. So if you wanted to connect over 80, let's go. Sure. With the socket connection, go and get all the data here. This one is all sorts of fun. My sock It's terrible. Variable names are terrible here. That's fine. It wants to stream, use an internet socket here, trying to go find, here's the connection on port 80, and then we're going to send it this command here because of the web server here. If we send it, hey, I want to get that information here, it should give us back that data, and we're going to receive some information. As long as there's data for us to read, we're going to go print out the data that we're getting back here, and then we close our connection. Look at that. We got a response. HTTP 200 OK. It's a good response. Here's date and time, all sorts of fun information, how many bytes was in here, the content, the type of content, and then the actual bit itself. So you get a whole bunch of other stuff here that we mostly ignore, that we don't usually use, we don't look at here. Our browser takes care of all that for us, and we get the actual content back out. So doing this by hand is pretty tedious. It's really nice we have browsers and tools that do that for us here. But we can go out to this page here on our browser, and we get the contents back out, right? So we can see that's what we got back. That was the text. If you open up your DevTools, that's F12 for DevTools. You can see all the other fun stuff we're getting here. Where's our response on my network? This one here. So if I'm looking at the network responses here, and I send this out, say, here's the Romeo text here. Here's all the other stuff we were getting, right? So here's the method, the response, all that other information we were getting, the content length, the content type, all that stuff is still captured. Our browser reads all of that and holds on to it here. That's all metadata that it's keeping here. The actual contents itself, it'll go display for us here. So don't write your own browser in Python, but if you wanted to, right, again, all this other stuff mostly hidden away. We don't want any of that here. We're just going to show them the actual contents here for the text. So we can connect in to web servers. Doing that by hand is not fun, but that's the quick example of using a socket here. If you want to get an image here, right? So looking for this particular JPEG here, let's go get that response here. Now we need to understand what's inside of a JPEG file, the actual bytes itself. I don't have that in my head. So apparently you skip over certain things here to find some picture length here, and then you can find that file here, right? And go write it back out. So we're skipping over all the other stuff that we don't want, right? All those other headers nonsense, all that other junk that we didn't need here. We're going to skip over that, find just the picture itself, right? After that header, we'll grab that information, write a binary file, right? This WB, I think we mentioned you can do binary files, but we're not going to do them because it's a big pain, and write the actual binary bits here that we got back as our JPEG, and we've got our file. And pretty tedious, we don't want that here, but here's the actual, all the bits that are coming through here. For that one, it's lots of fun. Thankfully, there's a library for doing URL stuff over HTTP. So the URL lib lets us manage all of that for us here. We don't have to open up sockets. We don't have to start those connections. We just say, hey, go open this URL here and give me back the results. So this is the much faster version here than doing it this way. And we get just our contents back. Right? So all the header stuff gets filtered out when we use our URL lib here. That's what we want. We don't want any of the other stuff. We don't need any of that other things. We're not trying to be a browser, just trying to get the data off of this here. So we can go and get some information off, put it on the screen, and see what we want to do with it. Now, that works well for things that are giving us text back here. You can get the binary files back, not having to do any of that other parsing here. You don't need to go get a bunch of images, but if you wanted to go grab a bunch of images off of someone's website, right, you can go grab their page, grab all the links of images, go download all their images here. You can do fun ones there. Yep. So if we wanted to parse this here and actually go to an HTML page here, like Dr. Chuck's page here, that has HTML behind the scenes, the text is not quite as nice here. Excuse me. So he will go and connect here. He's going to possibly connect over HTTP or HTTPS. So he's looking for all of the matches here for links. So he's going to go grab his website, look for all the links here, and print out all the links. So here's a page. Here's all the things it links to from that page. Right. sort of crawling along here. That idea of let's take a page, go to all of its links, and go to all of its links, and go to all of its links, and go to all of its links here. They're going along. So we combine some of the regex stuff with that here. So you can say, okay, here's all the links here from a particular page. So on docs.python.org, you link to all of these places here by using a regex, like looking for anything that matches, right? Whether or not there's an S there or not, right? Possibly it's there, colon slash slash, and then some sort of text, right? Find that link. Here's all the links for me. There's a library for dealing with HTML, which is really nice. We don't have to do this by hand here. So to use Beautiful Soup, we can go install the library. You can do all this by hand if you want with the pip tool. So he tells you, hey, you can go install it with pip if you want. Did he give you the line here? I don't think he did. In PyCharm, it makes it much easier for us. We go to our settings, and you go to your project structure. No, that's not it. Where did it go here? Editor? My goodness. Wow. Python interpreter. This one, Python interpreter. Sorry, there's so many different menus here. So the Python interpreter, and we want to add a package. So I'm going to find for this particular install, right? We did a virtual environment. So when I install a package, it's not going to install it to my main Python install. It's not going to gunk anything up there. So it'll install it for this specific one for week 5, which is a good practice here. And say I want to go add a library. I want to go add Beautiful Soup. I didn't come up with the name. I don't know why. It's called Beautiful Soup. Go blame Leonard. It's his fault here. We'll install the package. So what Beautiful Soup lets us do is get requests here and then go look for them. Hey, find all of the A tags here. So anything that's an A tag is our reference, our anchor tag. That's a link here. So it'll go find all of those tags here and we'll get the reference off of it. So you can give it a page here. Error. Oh, that's not good. It's just not our day, apparently. That's fun. Not likely pip subprocess. Let's just try it again. Beautiful soup. Beautiful soup. Let's try that. Maybe. Oh, maybe version 4. That's my problem. I didn't read Beautiful Soup 4. Sure. Let's try version 4. Maybe. Usually it gives you something there. Did I not hit it? Beautiful Soup 4. Install package. I think it's still trying to install. It's just taking its sweet time. Maybe. Nothing? Settings. Oh, there it goes. So one of the fun things you run into, and anybody who's interested in cybersecurity, this is a nightmare for you. I tried to install Beautiful Soup, and it also installed soup sieve and piping extensions. I don't know who supports these. I don't know where they came from. It's probably not malicious code. Probably. And the whole internet just runs on. I hope I didn't download a bad thing here. Um, did you hear about what's the new stupid bots, the agents that were like everyone was hyping up here? Oh my goodness. Yeah, malware in agents. Is it Moltbot or something? Claudebot. Yeah, this one here. Apparently Claudebot here, formerly Moltbot. Now, you can download plugins here to make them do things, right? And how many of them already have malware? That's the AI coding assistant. Oh, very exciting here. Um, you can get malware pretty quickly here by downloading the wrong stuff. And if you hand that to your AI agent you've given all sorts of keys to, you're in for a bad time. This was Moltbot or Claudebot. Okay, so now it's Moltbot. Okay. um, yeah. No, 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 no. Oh goodness. Yeah, this. Oh man. And they're not going to fix it. They're just don't install bad stuff because they don't have a filter process to make sure they don't get malware packages. Anyway, hopefully it all works, right? And we got good, decent stuff here. Um, that's a constant nightmare when you're dealing with that. Let's see. Let's copy all of that, right? So we don't need to actually download the beautiful soup. We did the pip install. So pip is what the command line tool. We use the PyCharm click button things to do it for us, which is nice. Hopefully that goes. So what's the request? What do we want to put it on? How about we take his book? Why not? Let's see if he has any links in his book. Oh, 403 forbidden. I don't think we're allowed to hit his website with a crawler. All right, let's try a different one here then. Um, what did he try? Python? Didn't he try? And that one worked better? Python.org. Try that one. Okay, that one's a little happier. Not everyone likes when you hit their website with a crawler, and there's some ways you can block it. Um, here's all the links. Very exciting. Here, finding all the tags. So that was all the links here. So all the references, right? Without having to do it by hand. We've got libraries, which is lots of fun here. Um, so anything you want to find in a file, you can get out with beautiful. Say, I want to find the tag, I want to find the content, find attributes, any sort of fun stuff here. Oh, does it work for Dr. Chuck? Okay, it does from his page one. There we go. Um, so this one must be allowed rather than the rest of his page here to crawl. You can go get more information out, which is really fun. So we've got some built-in libraries, so you don't have to do all that by hand here of parsing all of it, managing all of it here. And then I think we're in pretty good shape. So next week, then we'll get into the web services, which is much more fun here. Be able to do things a little bit more automated here, XML, JSON stuff. Um, that's the fun bit here. So working on how do I make a computer talk to a computer over the internet, right? And we get to do all this. It's really cool. And this will be the basis for our next project. It'll be fun. So um, get Wednesday, we'll get into the solution for project two. We'll get started on some of this stuff here and get started on the next project. We got the week after that to finish out our web services bit here. Take a little deeper dive into these, play with some fun stuff here. That should go pretty well. Okay. Great. Awesome. I will see you folks Wednesday.